Now in the previous video we have seen the linked list implementation as well as the multi-level indexing implementation. Now in Unix we are going to use a combination, right, which means by combining these two schemes the Unix inode is implemented this way. So in the Unix inode, if you look at it, attributes are going to be present, and then in the same node, see, this entire thing is one block, right? In the same block you are going to have some space allocated which is going to contain the direct pointers. Now these direct pointers will directly give you the addresses of the data blocks in which our file is present. Now, and again there may be a pointer which is second indirect. Now the second indirect pointer, second indirect pointer means that if you take this pointer and go to the data block which is pointed by it, it is going to contain the pointers which will point to the actual data blocks which will contain the data of the this particular file. Got it? Therefore, all these data blocks which are pointed here will be able to store the data of this file, as well as all these data blocks will also be able to store the data of this file. Now look at the number of blocks, they are increasing. Now like that you can have one more double indirect pointer. Now if I take the double indirect pointer and go to the data block, it is going to give us the pointers to other blocks, into which if I go there, again they are going to give me the data pointers. Now the data pointers which will point to the actual data blocks which will contain the data of this particular file, which means we are going to increase the number of data blocks even here, right? Similarly we can have triple indirect as well, right? Triple indirect, if I take the triple indirect and go, it is going to give me one particular level. And now if I take these pointers and go, then it is going to give me other data blocks which are going to still contain the pointers, and if I go still ahead, then they are going to give me even more pointers. Finally these pointers will contain the data of the file, right? That is why it is called as triple indirect. 1 2 3, double indirect 1 2, single indirect means 1. Got it? So by having like this, I can increase exponentially the number of data blocks that a file can have. Got it? Now there are all the data blocks which contain the data of one particular file, which is this one. That is how you can increase the you can store a very huge index file into just one block. So by taking this block you will be able to get the information of all the blocks. Got it? So this organization is used in Unix inode. Now one question is given in GATE based on that. Let's see that question. See this is given in GATE 2004 computer science paper. A Unix style inode has 10 direct pointers and one single, one double and one triple indirect pointer. Disk block size is 1 kilobyte. Disk block address is 32 bits and 48-bit integers are used. What is the maximum possible file size? So whatever organization I have just shown you, they are saying that they are using all that thing, and now they are asking us, if that is the case, then what is the maximum file size, right? So how to find it out is, you should be able to find out how many pointers you can put in one block. Based on that you can see the order of the tree. If you can compare it to the order of the tree which we have seen in B trees, then it will be easy. Otherwise without using that also we can see it. Okay, I'll just show you. Let's come to this diagram. Now they are saying that they are having 10 direct pointers here, which means the file is able to have 10 data pointers already, right? And then they are saying one single indirect pointer is there. If one single indirect pointer is there, then how many data blocks can it point to? That depends on how many pointers that you can have in this particular one block. Now that depends on what is the size of each pointer and what is the size of the block. It is given that the size of the block is 1 KB, which means 1024 bytes, right? And the size of each pointer is, they have given that the size of each pointer is 48 bits. Even though the size of the pointer is the address required is 32 bits, they are implementing it using a 48 bit number integer. That is why it is going to be 6 bytes. Now if you divide this, the entire number, this entire number is going to be 170 point something, right? So what does it mean? In one block I'll be able to store 170 pointers. Okay, in one block I'll be able to store 170 pointers and no more. So if it is able to store 170 pointers, then it will be able to point to 170 data blocks, right? Therefore here we are going to get 170, right? And now they are saying that one double indirect pointer is also there. Now if there is one double indirect pointer, which means that from here I will be getting one data block. Now this one will be having 170 pointers, which means 170 blocks will be present here, and each block is going to give us 170 pointers, and so finally we are going to get 170 into 170 data blocks from this, right? Now there is also one triple indirect pointer present, therefore this one is going to give us one block, and this one is going to contain 170 pointers. So the number of pointers coming out of this block is going to be 170, and at the second level we are having totally 170 blocks there. Each one is going to give out 170 pointers. So the total number of pointers that coming out of this one is 170 into 170, which means the total number of blocks present in this level will be 170 into 170. Now if each one is going to give us 170 pointers outside, the final number of pointers coming out of this third level will be 170 into 170 into 170. Each one will point to one data block. Therefore the total number of data blocks pointed out by this is 170 into 170 into 170. So by using this type of organization, a file can have a maximum of 10 plus this number plus this number plus this number of data blocks associated with this, allocated to that. Now given that each data block size is 1024 bytes, you can find out what is the total size or the maximum size of a file could be. So it is going to be 10 plus 170 plus 170 into 170 plus 170 into 170 into 170. This is the total number of data blocks we are going to get, and we have to multiply it with the size of the file. So size of the file, size of the data block. So each data block is of size 1 KB, which means 1024 bytes. So this is the total answer, but in the options they have given it in some powers of 2, which is wrong. Actual answer is this one, right? If you have to see the options, if you see the options, they are given it in the wrong, the answer is wrong. Okay, maybe the marks might be given to all the students who have answered it, but then the actual answer is this one. You are not going to get it in 2 powers, right? So if you have to get an answer in 2 powers, then if 32 bits is the size of the block address, maybe 32 bits must be used while storing the block address, but then they have given us that 48 bits are used. So if you are going to go with 48 bits, it is not possible. Got it? Okay.